In this video, I want to have a look at quadratic formula. So if we start off with a general form of a quadratic equation, so we've got ax squared plus bx plus c, where a, b, and c are all numbers. If we start with this and we complete the square on that, we rearrange it all, we end up with this here. So this is called our quadratic formula, and it's going to tell us the zeros or the x-intercepts of the equation. So we've got x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So we can plug the coefficient of x squared in for a, coefficient of x term in for b, and then we've got our constant term, we'll plug that in there for c. And when we figure it all out, it tells us the x-intercepts, which are also known as the zeros or the roots of that equation. The other thing that we can pull from this quadratic formula, is we can find the axis of the parabola, and from that we can find the coordinates of the vertex. So if we use just this first bit, so we've got minus b over 2a, so we're just using that first bit of that quadratic formula, then that gives us x equals minus b over 2a, and that's going to give us the x-coordinate of our vertex. Once we've got that number, we can substitute that back into our original equation and solve it for y to get the y-coordinate of our vertex. So we'll go through a few examples, and it asks us to use the quadratic formula to sketch each quadratic. So we're going to sketch our parabolas. So again, we need those key features. We need the x-intercepts, we need the y-intercept, and we need the coordinates of the vertex. So let's jump straight into using the quadratic formula. So we're going to have x equals, now in this, our a is the coefficient of the x squared term, so that's our 1. Our b is the coefficient of x, so that's our 6, so b equals 6. And our c is our constant term in the end, so that's 8. So we're going to substitute those in. So we've got minus b, which is minus 6, plus or minus the square root of b squared, so 6 squared, minus 4ac, so 4 times 1 times 8. And that's all over 2a, which is just 2 times 1. Right, so that's going to give us minus 6 plus or minus. If you figure out this whole thing, we've got 6 squared gives us 36, and 4 times 1 times 8 gives us 32. So we've got 36 minus 32 would give us 4. So we've got minus 6 plus or minus the square root of 4 over 2. But the square root of 4 is 2. So we're going to have minus 6 plus or minus 2 over 2. And now we're going to split this into our two different answers to solve them. So we're either going to have x equals minus 6 minus 2 over 2, or x equals minus 6 plus 2 over 2. And then we can solve each of them. So minus 6 minus 2 would give us minus 8 over 2, which is minus 4. And minus 6 plus 2 would give us minus 4 over 2, which is minus 2. All right, so that's the first bit. We've got our x and our y intercept, our two x-intercepts. To find our, I'm just going to draw this line down here. To find our y-intercept, we're just going to sub x equals 0 into this original equation. And we'd end up, well, this x squared term, 0 squared is just 0. 6 times 0 is just 0. So all we're left with is the 8. So we've got our y-intercept as well. And then we need our vertex. Now in this one, we could use that x equals minus b over 2a. But in this one, we can also just go, well, we've got two really nice, clean integer x-intercepts. And we know our vertex is going to have an x-coordinate that's halfway between them. So the x-coordinate of our vertex is just going to be minus 3, because it's halfway between minus 4 and minus 2. So this one, when they're nice, it's just easier just to look at them like that. And then to find the y-coordinate, we're going to substitute that minus 3 back into this original equation. So we're going to have minus 3 squared plus 6 times minus 3 plus 8. So that'll give us 9 minus 18 plus 8, and that gives us minus 1. So the coordinates of our vertex are minus 3, minus 1. Okay, so then the last thing we need to do is sketch it. Again, you guys should be using a ruler So draw your axes up using your grid book if you've got one. So it makes it a little bit harder for me on this thing. But okay, so we've got a y-intercept of 8, so we'll put that up here. We've got x-intercept of -4 and -2. So it's going to be about -4, -2. And we've got a vertex of -3. So -3 is there, and -1 is about there. So our vertex is going to be, about here. So drawing that in, it's going to come up here and pass through that intercept and up this way as well. Again, you guys should be using pencil tooling, trying to get that a little bit neater than mine is. Okay, so I just want to quickly run through a second example using all those same steps. So we've got a new expression here, equation. So we've got 4x squared plus 10x minus 7 this time. So we'll start off finding our x-intercepts. So our a is 4, our b is 10, and our c is -7. So it's important that you get that minus in there as well. So we've got x equals minus b, so -10, plus or minus the square root of b squared, so 10 squared, minus 4ac, so 4 times -7. And that's all over 2a, so 2 times 4. So that'll give us -10 plus or minus the square root. And if we put that whole thing, figure out all of that, it would give us 212 over 8. Then we're going to have -10 plus or minus. Now I want to simplify this third. So we're looking for square numbers that are divisors of 212, and we end up with 4. So we're going to have that 212 can be split into 4 times 53 over 8. But we know that the square root of 4 is 2. So we're going to have -10 plus or minus 2 root 53 over 8. And then just to simplify that a little bit, we can go through and divide everything by 2. So we're going to end up with -5 plus or minus the square root of 53 over 4. So that does leave us with two answers. We can either have x equals -5 minus root 53 over 4, or x equals -5 plus root 53 over 4. So there are our two x-intercepts. To find our y-intercept, again, we're going to substitute in x equals 0 into this original equation. So we'd end up, well, 4 times 0 squared is 0, 10 times 0 is just 0, so all we're left with is -7. So that's our y-intercept. And then we need to find the coordinates of our vertex. Now in the first example, we just went, okay, well, halfway between our two x-intercepts, but that time they were nice numbers. This time they're not. They're not nice numbers, they have surds in them, it's a bit messy. So instead, we're going to use that first part of the quadratic equation. So we've got x equals -b over 2a. So that's going to give us -10 over 2 times 4, which would be -10 over 8. And we can simplify that to -5 over 4. All right, so we've got all those numbers now. We're going to graph it. So drawing up our axes. Now these numbers at the moment aren't nice and neat and for us to be able to tell what they actually are. So we're just going to approximate them as decimals. So if you put this one in your calculator, you're going to get about 0.6. If you put this one in your calculator, you're going to get about, you're going to get about -3. So that just gives us an idea of where to graph those. Oh, hang on, sorry. I just realized I forgot to find the y-intercept, y-coordinate of our vertex. So to find that, we're going to have to substitute this back into our equation. So we're going to have 4 times -5 over 4 squared plus 10 times -5 over 4 -7. And that would give us -53 over 4, which is, if we wrote it as a decimal, -13.25. So the coordinates of our vertex are -5 over 4, -53 over 4. All right, so that's going to help. So now we can start plotting all these points. So we know it's going to have to come down. We'll draw our vertex first. -5 over 4 is only 1 and -1 1/4, so we won't go very far out. But all the way down to 13.25. Okay, so that's our vertex. We need a y-intercept of -7, so that's about half of that. So we'll put -7 there. Now we need this as 0.6, so that's going to be really close there. And that's going to be -5 plus root 53 over 4. I've got this one that's -3, so that's going to be about here. So that's -5 minus root 53 over 4. So it's a little bit messy, but now we're just going to join the dots. So from here, it has to come up through those two, and then up through this one as well. All right, so that's 2 examples of how we can use the quadratic formula to help us find the key features and sketch a quadratic.